Now we'll continue the class with the second problem statement, right? And this would be your second problem statement details. Now we'll see. The following data relates to a single stage impulse turbine. The condition single stage impulse turbine. And he has given some data. He has given as steam velocity equals to 600 meter per second. It is nothing but absolute velocity. And next, blade speed equals to 250 meter per second. It is nothing but u. And nozzle angle equals to 20 degrees. What is nozzle angle? How we are going to represent it as alpha. And again, the fourth parameter given in the problem statement is blade outlet angle. Blade outlet angle equals to 25 degrees. Blade outlet angle, how it is represented? Na? Fine. Right? And he has given some condition also in the problem statement. What is the condition here? Neglect friction. Again he says that VR1 equals to VR2. Neglect friction. Right? Okay, done. Now what you are supposed to find then? You are supposed to find work developed by the turbine for the steam mass flow rate of m equals to 20 kg per second, and also calculate axial thrust. These are the problem. These are the data given in the problem statement. These are all the known data, and this is the condition, and this is also known data, and these two you are supposed to find. What are these two? Work done and the axial thrust. Now we'll see how to resolve. If everyone if everyone are able to recollect the inlet and outlet velocity triangles, then it becomes easy for you to identify or calculate the unknown data from the given data in the problem statement, right? And now still here we will simply brief it as V1 equals to 600 meter per second and U equals to 250 meter per second. Alpha equals to 20 degrees and pi equals to 25 degrees. Mass equals to 20 kg per second. Right? Now, if you remember or if you can recollect how the inlet velocity triangle is, nothing goes wrong. Just until you get the exact inlet and outlet velocity triangles, yes, you can draw. Okay, no need to worry. Can you draw? Yes? Yes or no? Yes, you try to make an attempt. Meanwhile, I'll be drawing the same velocity triangle. Hmm? A, B, This is alpha V1 Vf1 from A to C. It is VW1. We are clear with that, right? Yes or no? Yes. After, here we'll change the color. After gaining the velocity of u for the blade, here we have a relative velocity Vr1. Angle here is theta. Theta, right? And again, from, let this point A, B, C, D. We'll mention this as D. Now, what is the value of AD here? It is U. Now, what is the value of DC? What is the value of DC? VW1 minus U. Right? Now, this is the inlet velocity triangle. Similarly, can we draw the outlet velocity triangle simultaneously so that both the triangles will be on the same page? Yes? Now, we'll draw the first what we are going to come across. We are going to come across the relative velocity VR2. Now, we'll draw the horizontal. X component and Y component. Right? And this is VR2. Y component is VF2 and X component is, what is X component here? This is the relative velocity, right? And it has come across after the traveling a distance of U. Okay, I have little bit confusion here. So I'll draw the velocity triangle for having this relative velocity, right? I've completed this relative velocity. Now I'll go with the absolute velocity. Okay, absolute velocity is represented as V2. Absolute velocity makes an angle of beta at the exit. Now I'm very clear like what is X component of V2. Can I represent it as VW2? Then what would be this? We will mention the points A, B, C, D. Okay. Now E, F, G, and this is H. Now what is the value of EH? It is U. If I want to know the value of GE, what is the entire value of GE? It is nothing but GH plus HE. What is GH? VW2. What is HE? U. Right? And if I know any of the terms like U, then I can get the value of VW2 in terms of beta. Or if I get the value of entire value VW2 plus U or GE, if I know the angle pi, I can calculate the entire value VW2 plus U. From that I can calculate the value of VW2. Are you clear with these two inlet velocity triangles? Now we will start deriving the statements one after the other. Right? Yes or no? Yes. Now, what the first point we are supposed to find? Work done. Work done equals to M multiplied by VW1 plus VW2 into U. Right? Yes or no? This is about joule per second. If I want to be in terms of kilojoule per second, just divide it by 1000. M into VW1 plus VW2 into U divided by 1000. Then what are the units? Kilojoule per second. Right? And from the problem statement, I know M value. I have to calculate VW1 to calculate VW2. And U is given for me in the problem statement. Yes, U is also known. If I am able to find the value of VW1 and VW2, I can get the value of work done. Now, and in order to know the values of VW1 and VW2, let us get back to the velocity triangles. Is any of the value given for you in the problem statement? Yes, nozzle is given, angle is given as alpha equals to 20 degrees. Any other value? Pi is also given, right? From this, VW1 can be found out or not, let me know. From the triangle A, B, C, can I get the value of VW1? What is VW1? It is V1 cos alpha. What is VF1? V1 sin alpha. Do I know the value of alpha? Yes. Now substitute here. VW1 equals to V1 cos alpha. What is the value of V1 given? 600 meter per second. And alpha is 20. This is 600 multiplied by cos 20. What is the value of VW1? It is 565 meter per second. Similarly, can I get the value of VW2? And again I have to jump to outlet velocity triangle, as we will see. Before getting back to the VW2, we need to apply the conditions. What are the conditions we can apply? What are the conditions I can apply here? In the problem statement itself, he said that there is no friction. If I neglect friction, the first one is VR2 equals to VR1. Very clear from that, right? And from this, I can find the value of VR2. How can I find the value of VR2? Do I know the angle of pi? Yes. What is the angle of pi given for me? 25 degrees. If this angle is pi 25, what is the value of theta here? It is again 25 degrees, right? And now if the value of pi equals to 25 degrees and theta equal to 25, I want the value of VW2. Okay, if I know the value of VR2. Yes, since the condition, if I apply the condition, yeah, I got the value of VR2. If I get the value of VR1, automatically I can get the value of VR2, right? And if I get this value and the angle is given pi here, can I get the value of VW2? That means with this pi, I can get the entire value of GB. Entire value of GB. And I know the value of U, right? If I subtract this value, that means if I want the value of VW2, it is nothing but GB. No, it is GH. It is GH. How to get the value of GH? GB minus HB. What is GB? VW2. Then what is GB? V GB is VW2 plus U. VW2 plus U. What is HB? U. Cross check. HB is nothing but U. Right. Now minus U. If I write this relation, finally I am coming up with the value of VW2. Okay. Now if I get the value of VW2 as 90 meter per second and Vf1, we can get the value from the previous inlet velocity triangle. Okay, from which triangle I can get the value of VW2? From the triangle EFG. Here I'll write from triangle EFG I can get the value of VW2. Yes, I got the value. And now, do I require anything here? Do I require the value of any of VF1 and all? No need. Just simply I can substitute here. Now we'll go for the next line. Now, since work done equals to mass is given as 20, VW1 is 565 plus 90 multiplied by 250. I can get the value of work done equals to 3275123 joule per second. If I want to express the same thing in terms of kilojoule per second, there ends the first bit. What's the second bit? You are supposed to find axial thrust. Do I have any relation for axial thrust? You have to remember m times of Vf1 minus Vf2. What is Vf1? Vf1 is nothing but V1 sin alpha. What is Vf2? V2. See, cross check. What is Vf2? I can write Vr2 sin pi. Vr2 sin pi. Can I write? Yes or no? Why? Because I know the value of Vr2. Why? Because Vr1 equals to Vr2 because of the condition. And even I know the angle of pi. It is 25 degrees given in the problem statement. Right? And from this I can get the value of Vf1. How? V1 is, what is the value of V1 here? 600 multiplied by sine alpha 20 degrees. And here Vr2, just now we have calculated, or if we didn't calculate also we can calculate Vr1. Here Vr1. How to calculate Vr1 ma? I want the resultant, right? Vr1. Can I go with the Vf1 by Vw1 minus U? Yes. Yes or no? Tell something. Tan theta equals to sin theta by cos theta. Yes. From this inlet velocity triangle Vr1, I can write it as tan theta equals to Vf1 by Vw1 minus U. Do I know the value of V1 sin alpha? Here it is 600 multiplied by sin 20. I know this value. Similarly, do I know the value of Vw1? Yes. Do I know the value of U? Yes. Can I get the value of Vr1? Yes. If I get the value of Vr1 from the inlet velocity triangle, can I equate it to Vr2? Yes. Okay. And now I can write the value of VR2 and the sine pi. Then the value of VF2 is 165 meter per second. Now I got the value of VF1 and VF2. Let me substitute in the relation. Axial thrust equals to mass is 20 and VF1, what is the value of VF1 we got? 205 minus 165. Therefore, the value of axial thrust is 800 newtons. Is this clear to everyone, ma? Yes? These are the two problem statements we can solve very easily without any clumsiness. And these are the problems related to a simple impulse turbine. Okay? In the coming class, we will discuss about a turbine where it has multiple stages. Okay? With this, we can end the third chapter. And there are many problems in your textbook. Even you can take up and solve. If you have any doubt, just you call me or you can text me so that I'll be helping you out in resolving these problem statements. Okay, now? Thank you.